This is section A6, choosing a factoring method. Recall that a polynomial is fully or completely factored when its greatest common factor is equal to 1. So example 1, here we have a couple of problems and we're asked to tell whether or not these are completely factored. Alright, well let's look at this first problem. We have 3x squared times the quantity 6x minus 4. Looking inside our parenthesis, this is not completely factored. We can still factor 6x minus 4 a little bit further. We can take out a 2. 2 is a common factor to 6 and 4. Alright, so we take out a 2 and we'll add that, and actually we'll multiply it with the 3x squared. So our completely factored answer should be 6x squared. And then in the quantity we have 3x minus 2. That's what remains after we factor the 2 out. Look at problem B, x squared plus 1 times x minus 5. Looking at these, there are no factors that we can take out of either of those binomials other than just a 1. So this is completely factored. Alright, example 2. Here I have 5x times the quantity x squared minus 2x minus 3. Now this trinomial looks very factorable because we have a negative 3, and if I'm looking for two numbers that multiply to make a negative 3 and add to make a negative 2, then I can use negative 3 times 1 to accomplish that. So this trinomial can be factored further. Right? We can factor this into the quantity x minus 3 times the quantity x plus 1. And of course 5x is still there. So this is our completely factored answer. Alright, let's go to the next problem. Here's a little caution for us. Students often get confused with this. This is not the difference of two squares. It looks very similar, but notice that instead of a minus sign, there's a plus sign. This cannot be factored. If it was x squared minus 4, then it could be. It would be x plus 2, x minus 2. Alright, again, asking whether or not these are completely factored. Well, for A, 5x squared times the quantity x minus 1. Other than just a 1, I can't factor anything out of x and 1. So this one is completely factored. Okay, look at the next one. Here I have 4x plus 4 inside the quantity. I can obviously take a 4 out of both of those, so it's not completely factored. So taking away a 4, I'm left with the quantity x plus 1. And notice that the quantity x plus 1 is being multiplied twice. So we could condense that by writing x plus 1 quantity squared for that. So there's the completely factored answer. Now to factor a polynomial completely, you may need to use more than one factoring method. And so the next slide will give us the steps to follow when factoring polynomials. Alright, so step number 1, always start with the GCF. Alright, first thing you look for when you go to factor a polynomial is try to factor out any common factors, ideally the greatest common factor. After you've done that, then if you have a trinomial that remains, you can look and see if that trinomial is the difference of, is a perfect square trinomial. Remember the perfect square trinomials, right? Where the first number is squared, last number is squared, the middle term would be twice the product of the first and second number. So I would look for that. And then also if you have a binomial with a minus sign, look and see if it's a difference of two squares. All right? So these are the first two things you should be looking for. And that's what we're going to concentrate on our next problems. Alright, so here I have 10x squared plus 48x plus 32. First thing I'm going to do is look for a GCF. Alright, what can I take out of 10, 48, and 32? Well, I can take a 2 out. So I'll do that. If we take a 2 out, what remains is 5x squared plus 24x plus 16. Okay? That's a trinomial. All right? Let me see if it's a perfect square trinomial. Let's see. The first term, x times x is going to give me the x squared, but unfortunately, this is not a perfect square, right? 5x times 1x is the only way to get 5x squared. Even though 16 is a perfect square, this is not going to be a perfect square trinomial. All right, so looking at my trinomial then, it's not a perfect square trinomial. The coefficient of x squared is a 5, so I'm going to use this method. B and then AC. Okay, so B is equal to 24, and then A times C would equal 5 times 16, so A times C is going to equal 80. Okay, two numbers that multiply to make 80 and add to make 24. Well, 10 times 8 would add to make 18. That's not going to work. How about 16 and 5? Well, that's going to add to make 21. That's not going to work. How about 20 and 4? 20 times 4 is 80, and then 20 plus 4 is 24. All right, so let's use those as our numbers that we're looking for. And remember what we did here? We make a box. The 20 and the 4 are going to go in the corners, and it's 20x and 4x. Our first term would be a 5x squared, and our last term would be a 16. Okay, so now let's factor. 5x squared and 20x I can take out of 5x. A 4x and a 16 I can take out of 4. Okay, let's go across the top. I can take out an x. And then across the bottom I can take out a 4. Okay, so this is going to factor into 5x plus 4, x plus 4, and I still have the 2 that I took out initially, so I need to put that in there as well. So there's our factored answer. Okay. All right. Let's go to the next slide. All right, factoring this completely. Now, first thing I notice, this is a binomial with a minus sign. It's a pretty good chance if I factor correctly, I'm going to be left with a difference of 2 squares. All right, so what's the GCF of 8x to the 6 y squared and 18x squared y squared? What do you think? Okay, the GCF is 2x squared y squared. And look what remains. 4x to the 4th minus 9. Is this a difference of 2 squares? Well, I believe it is. 4x to the 4th can be factored into 2x squared times 2x squared. And 9 would factor into 3 times 3. All right, so that difference of 2 squares would be written 2x squared plus 3 and 2x squared minus 3. And let's not forget to bring down the GCF and include that in our answer. Okay, so there it is. Doing great. We're moving along quickly. So let's go to the next one. All right, you can pause the video if you'd like and then rejoin us and see how you did. If you pause the video, welcome back. Let's start by factoring out our GCF. Okay, so what's the GCF of 4x cubed, 16x squared, and 16x? Well, if you said 4x, you'd be right. And what remains is x squared plus 4x plus 4. This is a trinomial, so I'm going to look and see if it's a perfect square trinomial. Well, x squared is a perfect square, and 4 is a perfect square, and then 2 times x doubled is 4x, so yes, this is a perfect square trinomial. So this is going to factor into the quantity x plus 2 squared. And let's bring down our GCF. Okay, and there's our factored answer for example 6. That'll do it for today's lesson. You've been a good audience. Thank you very much, and we'll see you tomorrow.